Thank you all for joining us today. As usual, before we start, I'd like to just go through a bit of housekeeping. So interaction with the guest speaker is exclusively through the chat. You won't be able to take the floor to speak, but please do feel free to ask any questions at any time via the chat. There will be a dedicated Q&A session toward the end to address your questions. If you have technical difficulties, you can't hear us, there are funny things going on with the platform, please try accessing via a private browser window. So you can do that in Chrome and Edge by pressing Control-Shift-N to get to a private browser, and that might resolve your issues. One other note is that this session will be recorded and available on Swapcard in the next day or so. So you can come back and watch it and go over all these interesting details about openEO at your leisure. So without further ado, I'd like to give the floor to Valentin Lupetti. He is Information and Communication Officer at the Directorate General for Defense, Industry and Space at the European Commission. He'll introduce our guest speaker. Valentin, the floor is yours.
Thank you, Evan. Welcome, everybody, and thank you for being with us for this third webinar of this hands-on presentation of the Copernicus data space ecosystem. So today, indeed, we have the great pleasure of welcoming two guest speakers from openEO. So we have Jeroen and Pratitya. We have the pleasure of welcoming openEO to present another API of the Copernicus data space ecosystem. So an API to access data sets of Earth observation data sets, and so access data and process data. I will give you the floor directly, and I hope that it will be very interesting and very, very hands-on. So Jeroen, the floor is yours.
Okay, thanks. And also from my side, hello, good afternoon, everybody. So if all is well, you should be seeing my screen now to allow me to introduce openEO a little bit to you. So this is a bit of an entry-level webinar, really going over the basics, trying to show some of the capabilities. It will not be long enough to really go very, very deep, but still we try to make it a little bit live so that you get a feel of what is possible and what it's about. I'm starting actually from the main data space website today. And if you're wondering, openEO is here under Analyze Data. You can find the main page and then actually also navigate to our documentation or some of the various portals that I will be using and showing further on in the demonstration. I will be using the DataSpace Jupyter Lab environment. It's also one of the menu entries in there. But of course, I already prepared it a little bit with the demo that I'll be showing today. So it's based on a Jupyter notebook, which allows me to be a little bit interactive. And at the same time, I will be using some of the openEO UI tools. So I might be jumping around a bit in my web browser. It's browser-based, it's an API, so yeah, a lot can happen in the browser, but programmers can also use, for instance, a regular development environment. But before I jump ahead of myself, well, let's start really with the beginning. What is it about? What is the problem that we're trying to solve? If for people that know Earth observation data, or even if you don't know it, if you want to do something with it, it can be quite tedious, at least in what we would call the classical approach before openEO or before that APIs became available. Because what you actually usually had to do was, okay, you identify a study area, find some products, and then actually download those to your local machine. Then you have a bunch of files on your laptop or wherever, and you need to do a number of processing steps to eventually arrive at an algorithm. And then to make things more complicated, now that we have the Sentinels and the Copernicus data sets that are rather large, this is in fact no longer possible for a reasonably sized problem or area of investigation. You would actually need multiple machines instead of just your laptop or whatever, and run this on the cloud. So then you would be getting virtual machines, you would figure out a way to parallelize things, distribute workloads, and so on, and might even need a team of cloud engineers to be doing all of that for you. So that is quite complex. And that is why actually multiple organizations had the great idea to solve this problem by building cloud platforms. And these cloud platforms, there's a number of well-known examples, like Sentinel Hub is one within the data space ecosystem. Externally, there's things like the Google Earth Engine, Microsoft Planetary Computer, and they all have the same thing, that they run in the cloud and then allow you to do data access and processing there directly. And the thing is that, in fact, there's different flavors. And that's then the problem, because you learn to work with one platform. But then if that platform doesn't suit your needs anymore, you want to switch to another one, then you have to go learn this other platform. So that's where openEO comes in. And in fact, adds a layer on top of these different platforms, or backends as we call them, that can have different technologies beneath them, but via a standardized interface, you are able to talk to all of them. And of course, there can still be differences, there will be different data sets and so on, but also a lot will be harmonized, will feel familiar once you have learned how it works, and make it easier to switch. And that is really the core of what openEO is about. Of course, as I mentioned, there's different ways of building platforms and features that you can add. So openEO also has a number of specific things in terms of added value that we found important when designing the system. And what I already mentioned is we try to have something unified, and that it's really simple. Hiding all this complexity, that is a key thing that we wanted to have in there, so that you don't need to be a cloud engineer to work with it. No, you can just be a regular Earth observation data scientist. All the science that you need to solve real world problems is already complex enough, so you don't want to need a degree in computer science to work on such problems. We also solve the scalable processing. So in the backend, you will be using multiple machines, but you won't see it. It's standardized. It makes different platforms interoperable. I covered that. It's also independent of underlying technologies. So it's very nice. You know that every couple of years something new comes along. And with openEO, if something that happens, as soon as somebody builds the interface on top of it, you benefit from new technologies without seeing it, and while sticking to the system that you already know. And finally, and it's really last but not least, we really try to support these fair and open science principles. When you generate data with openEO, we try to generate metadata that complies with these fair principles, again, so that you don't have to worry too much about it yourself. Okay, that is really the introduction. So now we get more into the live part. And for this, I will be using Python code. But in fact, openEO can also work with other programming languages. It's technology independent. And right now, there's already, for instance, also a library for R, JavaScript, even Julia exists. So you will interact with it in different ways. And Python is just one of them that I happen to be using today. And of course, it's a very popular language in data science in general. Now, the other way of showing the same thing, in fact, is right here. If I switch my browser window, it's actually the web editor. This is a visual interface on the same platform that shows a number of interesting things. And even without doing anything, for instance, you can see that there's collections available. And collections in openEO terminology are actually the data sets, if you want. And you immediately might recognize popular ones like the Sentinel-2 Level 2A data set. Or here we have a nice Copernicus elevation model. It has this map icon next to it, allowing me to even quickly preview it to get a sense of the data beneath it. And all this data and this interface is hosted on the Copernicus data space ecosystem. So we get it from there directly and also process it on machines in the very same data center as where the data is hosted. That is an important property. So this interface will come back later in the demo. You might see me switching between the Jupyter environment and this interface. And that is also how I actually use it in practice. The different interfaces are usable depending on what you're trying to achieve. Next to collections, the other very important thing is what we have is processes. This is actually the list of standardized processes that are supported in openEO. And this will be covered also in the demonstration quite a bit. But it's important to know that we have this rather long list already. So going back to Python programming for a moment. And explaining these backends, because the first thing that we then want to do is connect to it. Because, in fact, there's multiple backends. So you need to know the URL to connect to. And for the data space that is printed right here, it's rather simple at just openeo.dataspace. And because it's a web service, you also need authentication. And this is the default method. And the first time you use it, it prints this link, you click on it. And because I happen to be already logged in on the Copernicus Dataspace website, I just grant access to openEO. And now you see that it was successful. Luckily, you don't have to do this each time. When I just run the cell again, you notice, hey, it's no longer presenting me this URL. It's just telling me that I'm already authenticated. And this might look a little bit complicated, but it's really for, because we try to be secure, we try to comply with privacy regulations, that this system is in place and we are not just typing a password directly in Jupyter. So we are connected using Python, and we go on to the use case that we have today. Today we're going to use Sentinel-3 products to analyze heat waves, because Copernicus Sentinel-3 has an instrument which measures the land surface temperature, so we can see if that can tell us something about heat waves. Sentinel-3 is low resolution data, but it's actually very relevant because if we would go for the same workflow using the traditional approach, the thing that I'm showing today, if somebody would do it traditionally and he would come back 2 months later and saying, I'm done, then I would say, yeah, good job. Because you might not know, but the Sentinel-3 file format is relatively complex. So by the time you have figured that out, how to just get the data for a specific area, you will be a couple of days further. So in that sense, it's a good example. Yeah, that's it for this one. Maybe that's the other thing I wanted to mention. These notebooks that I will be using, we have a documentation portal on the Copernicus Dataspace there you find this nice link, Jupyter Notebook sample. And if you scroll to the bottom, you see there's the notebook Heatwave in the Netherlands. That is the one that I'm going to go through right now. So if I'm going too fast, you want to go back and check something, please go find it there. Get back to my Jupyter environment. So as you saw, it always starts by defining an area of interest. And today I'm interested in all of the Netherlands. Here I use a GeoJSON file, and I'm quickly displaying it just to give you a sense. And then let's already try to load the data. In openEO, that's done using this process called load collection. You see that the cell executes very fast. So you're wondering, perhaps, did he now already load all this data? No, that's not the case. It, in fact, is just defining the workflow, and the actual execution will happen later on. So nothing happened at all. And this is a very important concept in openEO, because what I did just now was creating virtually a data cube. A data cube is simply a multi-dimensional array with a space and time dimension. So what I loaded was spatial dimension, the Netherlands, time dimension, these dates, and this was actually somewhere from June to October, so covering the summer period. And this is now loaded virtually, not in reality, in this data cube, this three-dimensional cube. And there's also the bands that I loaded. So in this case, it was the actual temperature, it's the acronym LST, and a confidence layer allowing me to select the right pixels later on. So that's this data cube concept. I'm going very fast here, and it's important to really get it if you want to go a little bit further in openEO, and that's why there's also this QR code included, pointing to a MOOC that takes it a bit more slowly to explain this concept. Then I'm going to go further. I have these two separate cubes, and one was for masking. So I'm going to convert it to a binary mask. I happen to know how my confidence layer for Sentinel-3 is formatted, and that I need to threshold on this specific value, and I just apply this mask. And then these funny boxes that you're seeing here printed, this is the workflow that gets constructed step by step in the back in this notebook, displaying all these nice predefined processes that openEO will execute later on, not immediately later on. So I want now to add another step after my masking. And so now I removed cloudy pixels, anything that is not usable, which is quite a bit of data in remote sensing, got removed, and let's move on. And for my algorithm, it's actually non-trivial, and I cannot express it entirely using these predefined processes. You saw that there was this fixed list, and very often you arrive at this point where you say, oh, I would rather use the Python ecosystem, for instance, which I happen to know very well, or I have an existing library that I want to use, and work with that. And that's exactly what's possible. Anything that works with Python XArray or NumPy, because XArray is based on NumPy, can just be used inside of openEO. And here, for the sake of the example, we include Python code like as a kind of string, which to my feeling looks rather ugly. And what I usually do is I put it in a separate file and just load it from a file, and then I can edit the Python in there using any regular editor. The heatwave detection algorithm, it's XArray, again, makes it look rather simple. I'm not going to explain it in depth, but it will just, I think, return 0 or 1, depending on whether or not it was detected. And then I apply it over the time dimension. And this is again this data cube concept that allows me to work along certain dimensions of space and time. So this one is applied on all the observations of Sentinel-3, but for a single chunk. So not the full thing, but a single pixel. And that is what will allow the backend to parallelize things later on. So we have this apply dimension. And then my really last step in the workflow is to sum all the values. And this sum will tell me the number of heatwave days that have been detected here. And this is already my full graph. In fact, if I would, no, I'm not going to do this. I wanted to say if I want to show it, but that might throw up my nice demo here, which I don't like. So I'm going to the actual execution. And I'm going to execute it as an openEO batch job. For the sake of the demonstration, I'm showing that I can set some advanced parameters like the memory. Usually you don't do this, you leave this out, but it is possible, and there's a nice link explaining what these parameters are. It's a cloud-based system, so sometimes you have a larger problem, sometimes a smaller, so it's all quite tunable. In the meantime, you spotted here that my job was sent to the backend, and now it's actually doing something that is taking time. That's because it started the actual processing. I also gave it a name. It was sent up. It even seems to be running already. And that's because it's actually running as a batch job, which means like an independent job. I can even go away, shut down my Jupyter notebook, come back tomorrow, and the result might be there. The other way of running it is what we call a synchronous job. And then actually you say go, and then it just waits. And then if it's finished before the timeout, which is actually 15 minutes, you immediately get the result. So it's somewhat faster. It has less overhead than the batch jobs. It's suitable for small things, but the batch ones are more powerful. They can, for instance, run for 3 hours if you really would have a big problem. Actually, most of my jobs don't take 3 hours, to be clear. But let's say that I want to see what's going on, then I actually can go into my cockpit here, which was disappearing for a moment, so I am refreshing it. There we go, that went well. It's loading my list of batch jobs again, and then hopefully we will see that I have a job that is in fact running. It's taking some time. That's because I have quite a few long lists by always working with this system. And for instance, I can retrieve various things, but one of them is the logging information, which is actually quite complex, like almost an expert feature if you want. Most people don't understand everything that's printing in there, but it's mostly if there's errors or warnings and you want to reach out to the developer team, then it can be useful to copy paste the full error from here, go on the forum and say, hey, I have this problem, this is what's happening. Yeah, and then maybe if you advance, you might start to understand certain things, and it can help you see the progress or see if something is hanging or whatever. Those are the logs. Yeah, otherwise I'm going to keep it running here. I can even show my nice process graph that was created by Jupyter. It can also be shown in here. And sometimes what I also do is taking that and submitting it again only via this environment, because depending on my browser came complaining that something was slow, but it shows up. So you see those very same boxes. Or if I want to have a look in the back, I can even see the code and so on. But now, for the sake of time, let me leave this job running. It will create a netcdf file because that's what I asked for. openEO also support cloud-optimized GeoTIFF and a host of other formats. But netcdf was selected because, in fact, let me first stop this so that I can continue. As I mentioned, stopping my Jupyter doesn't stop the patch job, so this cell output is no longer relevant anymore. I continue with actually loading a netcdf file that I already created. Now this is happening locally, like in my Jupyter environment. And finally, if all goes well, I can plot my heat wave days. You see that land surface temperature records heat mainly in city areas, apparently, which I guess makes a lot of sense. And you see that it's a map for all of the Netherlands and parts of Belgium and Germany that happen to fall within the bounding box. If you want, you can also restrict it really to the polygon of your area. Good. That was already the whole workflow. So I'm almost at the end of the interactive part. But I do need to mention some important things, and one of them is credits. All of this, of course, runs in the cloud, so it consumes resources, CPU, memory. It's not for free, but luckily, the Copernicus is so kind to sponsor quite a generous public service that anyone can use, but to prevent people from using all the resources so that other people don't have any anymore, it is limited to a number, and it's now 4,000 credits per month that you get. And then if you know that this one on average takes only 5 credits, then you know that you can run quite a few of these jobs before running out. If I would go back into the UI environment, I now see that my job finished. I could download the netcdf, of course. If it's a GeoTIFF, then it even has a nice visualization feature. But I can normally also see the credits. That's what's under this detail button. And then I see that this job, it didn't take 5 credits. It was actually only 4. I get some nice memory. You see that actual CPU was being used. And one more thing I wanted to show is more towards the bottom. All of this is stack metadata for the experts, by the way. I see some nice statistics of my data that got processed, and a very long list, scroll, of Sentinel-3 products that got processed in my workflow. So what happened here, it did take a couple of minutes, but it was really a non-trivial list of products, Earth observation products, that got processed in here. If you would have to download only this, you would start this and have to maybe come back the next day or so. So that's what's visible in here. Then I go back to the final parts that we still wanted to cover. One thing very briefly is reusability. So if I'm very happy with this heatwave workflow and I want to share it with the world, then in fact I can do this on this algorithm plaza, which you can also click through via the DataSpace website. And you can host your algorithm there. It's a way of sharing it with the world or of finding other more complex workflows that others have created. A very popular one is these biophysical parameters. It's like leaf area index is already in use today by some of our users. Now, if you want to do this, share something like yourself, it's a bit of a process, but one of the most important steps is actually simply saving this process, give it a name like heatwave, and saving it as a user-defined process. And then it's ready for reuse by others later on. And that's it. I'm covering this part only very superficially, I know. But we're mainly looking for people still to populate more services. So if you, after this, manage to build something, then it would be nice always if you share it with the world. And then if I didn't forget anything, then we can now go over to my colleague, Raticha, if I'm correct.
Okay, yes, I think we covered that. Then I'll quickly share my screen. I assume you can see my screen. I hope so. If no, then yeah, someone just let me know. So the main objective of this webinar, of this session specifically, was to introduce you with what exactly is openEO and how it is important, or how it is being included in the Copernicus data space ecosystem. Since Euron already covered most of the part, or all the important parts of openEO API, I won't bore you with a lot of slides. However, I would like to mention a couple of points to summarize the things that we just discussed. Maybe I can start with the Copernicus data space ecosystem itself. So for the users who were not able to participate in the first session of this webinar series, we recommend you to, maybe you can also go back and have a look on what exactly is Copernicus data space ecosystem. But to summarize in just a single point, it is an ecosystem that is encouraged by the European Space Agency to bring all the data, to centralize the data and API at one single point. And one of those API is the openEO API, which is open source and a standard streamlined data access and processing API. With openEO, these are the main points that we always try to highlight, which is already covered by Euron. However, I thought it's nice to include even in the slides, because it highlights on how openEO makes it easy for remote sensing scientists or remote sensing data users to easily access data from multiple backends, and how the workflow is scalable and efficient. Furthermore, with the federation concept that Euron mentioned, you will be able to access data not just from the Copernicus data space ecosystem, but also from those different federated organizations. And the workflow or the data that will be prepared are fair and open science, which is already highlighted in the demonstration part as well. And if I have to talk about what are the data set that you can currently access using the openEO instance in CDSE are this. I won't go detail into this, but with the openEO web editor platform, you can go into detail of what are the different Sentinel collections that you can access, ESA world cover, as well as the vegetation indices. And saying that, I can also highlight that yes, we have additional data sets that's going to be there in the future. With this federation concept, as I said earlier, you can also access data set from the federated organization, and one of those would be Terrascope, which is already there as a Belgian platform that provides Copernicus products such as FAPAR, FCover. So those are kind of different products that you will find in the upcoming days in the ecosystem using the openEO instance within Copernicus data space ecosystem. This webinar was to give you a quick introduction. However, for the users who want to go into depth of how to deal with this data cubes cloud platform, and also to have a detailed understanding on the different features offered by openEO or the processes, we recommend you to go and have a look at this course called Clouds and Cubes offered by EO College. It is available for free for everyone. And yeah, in here you will not only get the theoretical knowledge, but also there are a lot of notebooks that you can practice, and let us know how you feel about them so that we can improve. Furthermore, Euron also already mentioned about this documentation that we have from the Copernicus data space ecosystem, within which we have this openEO entry point that will help you to get in detail understanding or how to get started with openEO, or understanding the different terminologies such as the backend, processes, collection, if you're already not familiar with that, those are already explained within the documentation. Additionally, I would like to also highlight this repository that we have for openEO, that is the openEO community examples, where we are already hosting more than 18 Python samples, which acts as a sample examples or the learning point for users. These examples include some of like parcel delineation using Sentinel-2. We also have the oil spill detection that we performed using Sentinel-1, and the heatwave one was the one that Yuran just shared. In addition to this, we also have many other notebooks, such as for calculating the best available pixel composite. And additionally, there is a notebook called LoadStack, which use the feature, which provides you with a feature to load data that is saved as a stack in a different environment, which will encourage you to use your own data within the openEO workflow as well. So please feel free to have a look at these notebooks. And by the name itself, I guess you can make an assumption that, okay, openEO community example, so it's a community for a repository. So if you also already are familiar with openEO, or you prepare an example and want to share it with the wider community, then we welcome you. Please create a pull request so that we can include it within the examples. And yeah, if you further want us to show it in the data space ecosystem, then once it is merged, we can also do that. In the process, if you find any error or issue when working with the workflow, then please submit ticket from the data space ecosystem support team. They will try to address as soon as possible. However, as openEO team and being open source, we usually encourage people to, if possible, post it in the forum, as it could be helpful for other users as well, and there could be some questions that you already could find an answers to. So I think that with that, I would also conclude my part of introducing you with the openEO instance within the ecosystem. And that was more or less about the openEO webinar. So I guess we can move to the questions if there are any.
Okay, fantastic. Thank you so much. That was a wonderful presentation. Very interesting too to see openEO working. Great that you have that preview to be able to see kind of what the data looks like ahead of time as well. I really like that. So we do have a couple of questions. So from Florian Zedek, he wants to know if it's possible, so about the credits, if it's possible under certain conditions to have a higher limit for credits, or is there a way to get more credits for processing?
Yeah, that's a common question. There are conditions, for instance, for Copernicus service users. So those that's usually decided if you're really this Copernicus service, and those are very specific conditions. Then we are onboarding it on the ESA network of resources. This is very relevant for ESA projects, but also their research institutes and so on can get actually on a yearly basis, I think it's around 4,000 euro worth of credits. And then the final option that is being worked on is actually just allowing people to buy credits via a regular system to just get them. Yeah. Those are the main things. And otherwise, it's of course not, us who arranges it. Is the European Commission and ESA who are responsible for the mechanism of who gets which credits. Huh?
Yeah, but it's already great, like you said. 4,000 credits is a lot for an individual user. That's a lot of credits.
Yeah, it's quite a bit.
Yeah. So he has another question about the algorithm Plaza. So is there a code review system for that? Is someone reviewing the code? Or
not yet, but we do have a mechanism where we try to indicate what are the prototypes, and if a user just pushes something on there, then it's generally a prototype. But then as a user, you can say, for instance, hey, look, I wrote a scientific paper about this, showing that the results coming out are actually validated and good. And you send us the paper, so to speak. And then it can go into this validated status. So that is currently what we have in mind there. Generally, you could also allow other users to review each other, but that's, for instance, not yet there. It's currently more the, let's say, scientific approach based on any evidence that the author provides that it's in fact working.
But then it becomes a very useful resource if it's kind of scientifically validated, a useful resource for people coming and looking for methods to process this data. So
exactly, that's the idea.
Yeah, community done things are great, but sometimes you need a little bit of insight.
Then those 5 stars, you know how it goes, right?
Yeah, exactly. It works for some people, maybe not for others.
Yeah.
I don't see other questions, but I did have a couple for you. So kind of about change. I see there are lots of resources for individuals, especially to go and learn about openEO and how it works. But as you know, within organizations, the organizations often get stuck in the way that they do their workflows and things like that. So maybe they're stuck direct downloading, using Snap or QGIS to process the data. So for organizations specifically, do you have any advice for people on maybe how to push the organizations or how to kind of start using the cloud for running these workflows as opposed to kind of the old ways?
Yeah, indeed, how you change it. We see a lot of people doing it rather in a gradual manner. For instance, a lot of users right now are using the data access and download capabilities of openEO, and then they still do other processing probably locally on their machines. And actually, for us, that's just fine. We build it and we try to use it ourselves really as an end-to-end processing system, and really we are pushing the boundaries there. But it's just fine if you do some basic pre-processing in openEO. Often that already reduces the data a lot. We have, for instance, nice compositing algorithm examples where you maybe go to a cloud-free monthly composite of Sentinel-2. And that's a useful input to a host of other algorithms and software toolboxes that you might have available locally. And for us, that's just fine. And then you can have this, easy migration path where you, in a kind of step-by-step manner, start to use it.
Yeah, so I didn't even think about having hybrid workflows as well. So where part is in the cloud, part is local, depending on. That's very interesting.
Actually possible. Because it's, for instance, you have the Python library, so it fits in quite well with a Python workflow. Of course, we do have to mention that you do have to be careful with using it as a download interface, in the sense that certainly the classical S3 download for like bulk download is the way to go to keep it. But if you're interested in like specific areas in the world with a non-rectangular area of interest and so on, then we do see people using this custom download and basic pre-processing. That is certainly something we're good at. Also, the backscatter computation of Sentinel-1 is certainly worth mentioning there. It can do it on the fly. So instead of working with a much more complex Sentinel-1 GRD or even SLC files, you immediately get the backscatter, and then you get the pre-processed data and can go from there.
Yeah, so it seems like there are lots of options for new users, and even within organizations, ways they can save time and cut corners on their processing. Yeah. That's super interesting. I do have one more question for you. I know that you're maybe expecting this, but I was curious about the use cases. So I know that you've implemented some recently. Can you tell us a bit about those?
Yes, we have plenty of use cases now available, and it's available not only in documentation, but also in the main website of Dataspace. So we have already implemented use case basically in the remote sensing field. So some of them, one of them was the one that just Jeroen showed on heatwave. The other includes volcano and also landslide and all those things. In addition to this, there are a couple of more use cases that are going to come in future, which are, some of them includes like ONXX machine learning inference using openEO. So those, as well as the random forest-based implementation using openEO, will also be there available in future. And additionally, our openEO team the openEO team tries to come up with different use case every time a new feature are released in the CDSE, especially with openEO instance and CDSE. So we will be always trying to come up with new use case in this scenario, which will be reflected even in the data space website itself.
Yeah, so add a feature and then show people how it can be used, right?
Yes,
Yeah.
that's the idea.
Fantastic. So we do have another question from Firmin Hadi, and he would like you to explain briefly on the workflow how to integrate openEO with Open Data Cube. So he's working on a project with the Indonesian Ministry of National Development and planning to utilize Open Data Cube.
Yeah. There's a complex answer and an easy one. There happens to be a backend that even works that was built for Open Data Cube, if I remember. It used this Xarray and Dask technologies, and then like you deploy it on top of an Open Data Cube. But that's rather advanced already. The other way I would say is that openEO is very compatible with stack metadata, and a lot of these tools in the Open Data Cube and Pangeo ecosystems that this is about are also now looking towards stack. So one thing that openEO can do is it can load data via load stack. So that has a stack metadata. We can load it and then process it together with data coming from CDSE, for instance. The other way around is when we generate the data that you saw today, you also have the stack metadata, and then it's sometimes rather easy to ingest in tools like an Open Data Cube, or to load it directly with tools from Pangeo and do it like that. Sometimes even without downloading the data. It depends a bit on the complexity of the case, but it's rather intercompatible with Pangeo style, with that ecosystem. Yeah.
And maybe just to help Firmin out, is there something about this in the documentation that we can point him to?
Good question. I think we have one sample on the load stack. Am I right, Pratitya?
Yes, I will try to quickly share that in the chat. Yep.
And we have another question as well from Pier Lorenzo Marasco. He's asking about the backend. So talking about backend, is the Terrascope from Vito the only backend available through CDSE?
No, in fact, this might be coming from this picture we showed where Terrascope was included. But I should explain this a bit better. This is a new thing that we are working on, and you might see a news update over the coming weeks on that. It's this openEO Federation, and that's indeed a combination of backends where in the very beginning, it will be the CDSE one and the Terrascope one from Vito, for the very simple reason that we happen to be the same organization. So it was rather easy for us to add this as a first test. But what we also did, that's going to appear on the documentation portal, is describe how other backends can apply to join this federation. And we, of course, hope that we will get some offers that want to do this of other compliant backends, and that we will then also add. But of course, it is first needs to be released, and then we will see who will apply for this. But we hope that we will get some applications. Yeah. To really grow this federation. In fact, the Copernicus data space is a data space, and the concept of such a thing is really to try to combine a lot of remote sensing data, public, non-public, commercial maybe even, and openEO is really one way that this could be achieved, this federation mechanism.
Fantastic. I'm looking in the chat here for other questions. I don't see any other questions at this time. Did anyone, Joran or Pratisha, did you have any other comments or anything else that you would like to mention?
Not from my side, no.
Yeah,
it's very nice.
Yeah, not from me either, I would say. However, yeah, I would encourage everyone to, if they come up with question after this webinar as well, they can always come back in the forum and post it there. So we are quite quick, I would say, to respond back in the forum. So, yep.
Well, thank you very much, both of you. I think at this time I'll go ahead and hand the floor over to Valentin to close our session. Valentin?
Yeah, thank you, Evan. And thank you, of course, to our guest speakers today. I think it was super helpful for anybody willing to process and access Copernicus data and Earth observation data. Thank you as well for integrating this interoperability as part of the challenge of your solution. It's super helpful when dealing with different tools.